Recently, ChargerLAB has taken apart the ultra-thin 65W GaN charger from AOHi. Many audiences asked us what is the difference in charging performance between this ultra-thin charger and traditional chargers. So today we'll do some charging tests to find out the results. As we mentioned in the teardown video, its model is AOHi 65W. It supports input of 100 to 240 volts, 50 or 60 Hz, 1.6 amp. The maximum output in PD mode can reach 65 watts, but under the PPS protocol, the highest power only reaches 33 watts. The charger adopts a translucent design. The AOHi logo, the 65 watts, and the word feature are marked on it, and it looks like a biscuit. The yellow USB-C port is at the output end. There are two magnets and a groove between the two prongs that allow the user to easily unfold the casing. The prongs can be rotated, saving space in the socket and make it more flexible to use. After unfolding the casing, the charger can be plugged into the wall outlet more stably. The indicator light has 3 states for you to quickly check the charging status. It lights up yellow when fast charging, blue when standard charging, and green when trickle charging. And the size of this charger is about 104 by 60 by 14.5 mm, but when the case is unfolded, its length is reduced to about 87 mm, and it weighs about 96 grams. To put it into your pocket, it is thinner but larger than the Apple 70W charger. ChargerLAB PowerZ KM003C shows it can support UFCS, FCP, SCP, AFC, QC 3.0, 5, PD 3.0, PPS, DCP, and Apple 2.4 amp charging protocols. It has 5 fixed PDLs of 5 volts, 9 volts, 12 volts, 15 volts, 3 amp, 20 volts, 3.25 amp, and a set of PPS. After the brief introduction, let's start with the compatibility part. For all PD devices like phones, tablets, laptops, etc., they can be charged without compatibility issues. It can also support 3 Mbps and QC5, so most Android phones can be charged more than 20 watts. Next, we'll use it to fully charge the iPhone 15 Pro. We put the charger into a 25°C thermal tank throughout the test. Here is the charging curve made by the PC software of KM003C. The voltage stays at 9 volts first, and the charging curve can be divided into 5 parts. In the first part, the peak power stayed at 20 watts from the first 18 minutes. Then the power gradually drops to 16 watts, 11 watts, and 6 watts in turn. At the 48 minutes, the voltage dropped from 9 volts to 5 volts. The final part begins at 1 hour and 7 minutes, and the power slowly drops to almost 0. It takes 1 hour and 40 minutes to be fully charged. We plot it into another curve to see how fast it can be. It can charge the iPhone 15 Pro to 50% in 24 minutes, 80% in 51 minutes, and 100% in 1 hour and 40 minutes. Since it can support up to 65 watts, then we're going to use it to fully charge the MacBook Air 15 inches. The voltage fluctuates around 20 volts, and the charging curve can be divided into 4 parts. In the first part, the peak power stayed at 61 watts for the first 43 minutes, then the power gradually drops to 51 watts and 33 watts in turn. The final part begins at 1 hour and 19 minutes, and the power slowly drops to almost 0. It takes 2 hours and 20 minutes to be fully charged. We also plot it into another curve to see how fast it can be. It can charge the MacBook Air 15 inches to 50% in 37 minutes, 80% in 1 hour and 8 minutes, and 100% in 2 hours and 20 minutes. Next, let's plug it into the PA300 power meter to test its standby power. The power consumption at 220 volts, 50 Hz is 0.07 watts and 0.03 watts at 110 volts, 60 Hz, which is about 0.613 and 0.263 kWh in 1 year respectively. So you do not need to worry about the waste of the electricity. Next is the conversion efficiency test. The conversion efficiency varies from 84.6% to 92.11% at 220 volts 50 Hz, and the conversion efficiency varies from 85.08% to 90.67% at 110 volts 60 Hz. The conversion efficiency maintained around 90% at different output power, which is above average compared to other products. Now let's do the ripple test. The low ripple means better quality. First, let's check out its ripple without load. When the output is 20 volts 0 amp, the lowest ripples are around 30 and 27.2 millivolts peak to peak. The ripples are relatively higher at 78.4 millivolts peak to peak when the output is 9 volts 0 amp. And it also reaches 69.6 millivolts peak to peak when the output is 5 volts 0 amp. That moved the ripple test when loaded. All the ripples at different output power are around 40 millivolts peak to peak. When the output is 5 volts 3 amp, the highest ripples are around 43.2 and 47.6 millivolts peak to peak. The ripples are relatively lower at 36.8 millivolts peak to peak when the output is 12 volts 3 amp. And it's also 41.2 millivolts peak to peak when the output is 15 volts 3 amp. Overall, its ripples are slightly higher than similar products, especially at no load. We also put the charger into a 25 degrees Celsius thermal tank throughout the test, and recorded the highest temperatures on the front and back after charging at 65 watts for an hour. Under 220 volts 50 Hz, the highest temperature on the front is 66.3 degrees Celsius, and the back is 69.1 degrees Celsius. Moving on to the 110 volts 60 Hz. The maximum temperature on the front is 72.1 degrees Celsius, and the back is 74 degrees Celsius. Plotting the data into a bar chart, as we all know, temperature is difficult to control in the ultra-thin body. So the maximum temperature is very close to the upper limit of 77 degrees Celsius, but it still complies with the IEC 62368 standard. Well, that will be all the tests for this ultra-thin charger. Due to multiple protocols, all devices we tested can be successfully charged with this charger, and its standby power consumption and full charging are at normal levels. What impressed us was the excellent conversion efficiency, but its ripple and temperature test results are not as good as we expected. So it's very suitable to charge your devices on the go. Okay, that's all for today's video. Please drop a like, leave your comments, and subscribe to us. Don't forget to click the corners to check the teardown of this charger. See you next time. Bye.